Hello guys, welcome back to my channel Memo African Motives. Still working on engineering science and 2, still on the question paper which was actually written in February 2022, working on separate chapters as we are doing these chapters at different levels. So we are going to work on mechanical drives and lifting machines. So probably guys, you're new to my channel and your first time, you can actually become part of the family Memo African Motives by subscribing so that you won't miss any of the classes that we shall be having from Memo African Motives. So guys, that's it. Let's quickly rush through the question that we are given on mechanical drives and lifting machines. We are asked to list 3 types of gears. Okay, so the 3 types of gears that I'm having for you on 5.1, these ones, that is the types of gears. We've got the bevel gear, the spar gear, the worm gear, and also the rake and the pinion. So actually you can use these ones for the typical types of gears. Okay, so that was on 5.1. Then on 5.2, give 3 methods of reducing belt slip. So belt slip, you know that guys, when you are dealing with belts, if we can actually tighten them or to use a material which is of higher friction coefficient, that is something that can actually reduce all these belt slip. So I think best, let me just give you these ones. I think they can be best if you write them down. Okay guys, so methods of reducing belt slip. Tighten the belt, guys. I think this is straightforward. Okay, you have to tighten the belt that you're actually using. Use belt material with high friction coefficient, that is so that it can resist much friction. All right, so increase the angle of contact between the belt and the pulleys. Remember, belts, pulleys, they work hand in hand. All right, a compound gear drive with on 5.3. So we are now on 5.3, where we are given that the compound gear drive with gear A as a driver which is driving gear B. Take note guys, gear A driving gear B. Gear B is coupled with C which drives gear D. All right, so this is the information that we are given, and I always like write this, draw this in a simpler manner so that you can actually understand what's happening. Yes, maybe some doesn't make sense, but I hope to some it makes some sense there. You just have something like this. Okay, so let's say this is your A, this is your B. A is driving B. Okay, then B is coupled with C. So if it is coupled with C, there's something that they are actually talking about there. Let's just say something like this. Okay, this is your C and this is your T. Okay, don't freak out guys, this is just a presentation, okay, that I just want you to see, to understand what's actually happening here for answering question papers. Okay, we are talking about answering question papers. So what is going to happen is that the A, the B and the C, they are coupled. Okay, so what they do is that they share the same rotational speed. That's the only thing that they can actually share, which is the rotational speed or the rotational frequency. So that means in this case your NC is actually equivalent to NB. That's the only thing that is important about this coupling thing. Okay, and also you must know that this is the driver. Okay, where can I write it? Let me write it here. This is your driver. Okay, so which means B will be driven at that moment, and your C is also your driver. Okay, and your D will be driven at that moment. Okay, so that's the concept guys. So let's just list all the information so that you can actually answer this. It's best that you just have that presentation. Okay, it's gonna be easier for you to answer this. TA is 44, TB 60. Okay, so we've got TA here on A. We've got TA which is actually 44, and I've got TB which is 60, the number of teeth which is 60T here. All right, so then okay, let's just put the T so that someone is not confused. Okay, then NB, that is the rotational frequency there at B is 24 revs per second. Okay, so for B, NB, that's actually 24 revs per second. Like I said, that NC is equal to NB, so which means that NC we also have 24 revs per second. That is what is only important there. All right, then TC is 40, the number of teeth here at C it's 40. So the number of teeth, they're different, they're not the same, but it's only the speed because they are coupled together. Then D has got 15, so the number of teeth here at D is 15. All right, so the first question here is to calculate the rotational frequency of gear A. So we need the rotational frequency of gear A. Okay, so what's important about this is that we know that the relationship between the two, that is 5.31. Okay, let me just write it here, 5.31. So we know that the relationship between the number of teeth and the rotational frequency, the product of the driver is equal to the product of what? Of the driven. That's the concept there. So you can actually write this as a NA, the number of the rotational speed by the number of teeth on A is equal to NB times TB. Just like that, guys. You can actually memorize this, but on actually to know the concept is best how you actually work with this and just substituting. Okay, so you can actually suppose this is in your formula sheet also, so we can make a NA the subject because that's what we need here. So we can make this to be the subject. Remember from your mathematics, guys, if you want NA, you're going to divide by TA. So number of teeth at A is going to be NB by TB over TA. So you can actually substitute this from the information that you are given. Remember, we are given NB, it's 24. So we've got 24 times TB, your TB in this case, which is 60T. So we've got 60 over TA. Okay, what do we have there on TA? Our TA in this case is 44T. This is a T, guys, take note. This is a T there. So it's 44. So something like this. All right, so if you work out this properly, guys, from your calculator, it's a matter of using the calculator properly. Okay, you are going to have your NA. You put a fraction. Actually, that's what you're going to do. You just put a fraction like this, guys. Okay, so you just put a fraction on this part here. Okay, this is the fraction that you're going to put. You just put a fraction, then you multiply 24 by 60. Then you actually divide by 44 like that. Okay, so you're going to obtain that 360 over 11, then change it using this SD button here. It's going to be a decimal, which is something like 32.72, whatever that you're going to have. Then you can round off to 2 decimal places or just 3 decimal places, depending with the degree of accuracy that you actually want to use there. All right, so that is your NA. That is the NA there. So let's see another part that we are given. So actually these questions, they just repeat the same thing. Okay, they just repeat the same thing. All right, so let's see what we had on the other part. We need also to calculate the rotational frequency of gear D. So the rotational frequency of gear D. So this one, they know that most of us, we are going to confuse here because take note, we need ND. We are just given the number of teeth at D. But using this concept, guys, remember, we were not given this rotational frequency at C. We were not given, we were just given the one at B. So taking that part that I told you guys, that these two are actually equal. So that is where most of us go wrong there. So you need to correct that part and be very careful, guys, on this stage. Okay, so what I'm simply saying is that these two, they are equal. So it's actually a continuation that you're making to say that NB is equal to NC. That is the rotational frequency, so which is actually equal to 24, like what we wrote, revs per second. So if I have this NC, how can I find ND? I now know that since C is driving, because C is the driver and D is driven. So if this is driving D, therefore we have to call the same relationship again. NC by TC should be equal to, and as long you are driving, as long there's a driver and the driven, the product of the rotational frequency and the number of teeth is going to be equal. So since we need for D this time, you need ND, so you're going to make then ND to be the subject, so you divide by TD. Okay, so actually ND is going to be, if you divide by TD here, it's going to be NC by TC over TD. Okay, so you can actually substitute there. So your NC is the one that you are referring as NB because they are coupled together, so they have same speed. So that's your 24 times TC. TC already you were given the number of teeth here, which is 40 teeth, which is 40 T, over the TD. For TD already also you were given, for D we are given a 15 there. Okay, so you can actually substitute 15. So just like what I did, put a fraction there, these two on the numerator and this one in the denominator, you're going to obtain 64, direct 64. So this is gonna be 64 revs per second, which is your NT. So that's what you have here. We've got 64 revs per second here, 64 revs per second. That's what we had. Okay, so that's how they can actually ask these typical questions, but it's not new to you guys, because I remember we have been talking about these typical questions for quite a long time, so you can actually relate these typical questions. Okay, so it's not something to most of you. Calculate the velocity ratio. Okay, so you know that the velocity ratio can be calculated in two different ways. I've talked about this also before, about the velocity ratio. So remember, we say that the velocity ratio can be, this is 5.33 if I'm not mistaken, that's 5.33. So you say that the velocity ratio is actually equivalent to the product of T. All right, let me just write this, product of T that is on the drivers. Remember, we've got the drivers there. Okay, we're going to talk about it, over the product of T which is being driven. So that's the concept there. Okay, the product of the T there is representing the number of teeth, number of teeth on the drivers. Okay, so remember guys what we talked about. We say A is the driver which is driving, actually this is driving B, and C is driving C. So A is the driver and C is the driver, so it's going to be product of TA and TC. So it's T for A times T for C over the product of the driven, the ones which are driven. B is the one which is the driven and D is the driven, so it's TB and TD, something like that. TB by TB, TD, like this. So once you have this like this, you don't worry much, you just substitute here. So TA is already there. This is our TA, which is 44, and our TC, we calculate it was there also 40, so it's 44 by 40. You just substitute this 44 by 40 here over the product of TB and TD. Okay, so you have the same thing, our TB, that's 60, and our TD, in this case, that's a 15. We have a 15 here, so it's 60 by 15. All right, so that's actually the normal formula that you can use. Okay, so you just have to multiply properly. So from your calculator, you're going to obtain something like 88 over 45 if you multiply properly, but change this to a decimal. It's gonna give you something like 1,9555555, something like that. All right, up to a 6 at the end. All right, but this is a ratio, so therefore the velocity ratio actually is going to be, just round off, it's gonna be 1,956. Okay, let's just say 56 as to 1. So that will be the velocity ratio now. All right, or we could have just used the number, the rotational frequency. Actually, besides using the number of teeth, we use the rotational frequency. When we use the rotational frequency, what is going to be the formula now? When you use the rotational frequency, it's going to be, let me write it here. If you use the rotational frequency, it's going to be the rotational frequency of the driven, the final driven, over the rotational frequency of the one that started with, is the driver. Rotational frequency of the first one, which is the driver. So it's the final driven over the first one, the first driver that we are given. So the final driven, that is your ND here. This is the final. Remember, A is driving B, C drives, so this is the final driven. final driven, which is the rotational frequency here, which is 64 revs per second. So you have got 64 revs per second over NA. Your NA, we calculated this. We were the ones who calculated this NA, and we obtained something like 30. Remember, 32.73. All right, so you're going to divide by 32.73 like this. All right, so let's see, let's cross check this one. I didn't even focus on this method, but let's just see. Okay, so just put a fraction there, then divide 64 over 32.73. let's see if you're going to obtain something else. We're going to obtain 1.95539 and so forth. Okay, so that will be the velocity ratio definitely, which is going to be 1, 2, 3. Just write round off, which is 1.955, but this one is going to be 55, as you can see, 55 there as to 1. Okay, so it depends with the degree of accuracy that you rounded off the first part, and also the formula that you are using. So this one gave us 1,555. It was 55555. That's why it has to change to a 6. So using this part, guys, this is what you're going to obtain. But using this part, that is what you're going to obtain. So focus on the method or on the formula that you have used. Okay, you have to stick to the formula that you have used. There is no wrong in that. All those answers, they're actually part of the answers. They are fine like that. All right, on 5.4 we are then given a machine has an efficiency of 35% as the load moves 100 millimeters and the effort moves 2 meters. Okay, so remember, guys, what we are having there, we have got an efficiency of 35%. Okay, 35%, and in this case the load is actually moving, that is the distance of the load. So you can just write S load, the distance of the load, which is here. They're given the load moves 100 millimeters. Okay, so 100 millimeters, guys, to meters, you can actually convert this to meters, which is divide by 1000. Milli divided by 1000, so it's gonna give you something like 0.1 meters. You divide by 1000, this one divide by 1000. All right, then we've got the S, the distance for the effort. Okay, the effort moves 2 meters, so the effort is fine. The effort is going to move 2 meters, something like that. All right, then calculate the following. So the first part is to calculate the following: the velocity ratio of the machine. All right, the velocity ratio of the machine. So how can I calculate, or how can I have the velocity ratio of the machine? We actually talked about this before, guys, that when you are given find the velocity ratio, we are going to obtain this from the formula, or from the distances which were moved here, because we have got the load and the effort. So the formula is velocity ratio is equivalent to the effort distance. Let me write, and I'm going to replace with what we have here: effort distance over the load distance. So if this be the concept, it means it's just the effort distance, which is this S effort over S load. So you can just write like this one S for distance, like that. All right, so it means it's just a substitution. Therefore the velocity ratio is going to be, the effort is 2 meters, so you've got 2 over the load is, so take note, if these are meters, these are also supposed to be meters. If you use millimeters, therefore you're supposed to convert these to millimeters. That's another option. So you divide by 0.1. okay, dividing properly, you're going to obtain 20 from your calculator. All right, so that's it, guys. That's your velocity ratio, straightforward like that, guys. Don't think much, don't assume much, guys. Okay, so actually this we shall be working with these full papers. Is going to help us also to cover a lot. Okay, the other part we are given the mechanical advantage of the machine is and 2 marks for that, the mechanical advantage. Okay, so how can we have the mechanical advantage? We now have the velocity ratio. Remember, the velocity ratio is nowadays 20, so you can take advantage of the velocity ratio and the efficiency here, because we've got the efficiency. Okay, so let's take advantage of that because the velocity ratio is there. So 5.42, so we know that when we are given the efficiency, we can take advantage of this, because we know that efficiency is actually the mechanical advantage over the velocity ratio. So we can actually substitute this. When you are given the efficiency, you have to convert it to a decimal. The efficiency is 35%, okay? So 35% is equal to 35 over 100. That is what it means, 35 over 100, which is equal to 0.35. That is what 35% means as a decimal. So it's 0.35. So 0.35 is equal to the mechanical advantage, which is the one that you want to calculate. So it's going to be mechanical advantage over the velocity ratio that you calculated before. Remember, it was 20. We calculated this velocity ratio here and we obtained 20. All right, so then what am I going to do? Substitute, cross multiply, they solve the equation, because it's now a normal equation, because this one is ms over 1. From your equations, guys, from your mathematical skills, what are you going to do? You can actually cross multiply here. So that means the mechanical advantage is going to be 20 times what? 20 by 0.35. 20 by 0.35. All right, so if you multiply 20 by 0.35, you're going to obtain 7. That will be our mechanical advantage of a 7. So that's how the question was laid out on this topic, guys. So as you can see, it's very, very pretty to revise much questions so that you can be familiar to these questions pertaining different typical questions actually. But that's it, guys, from Memo African Motives, working on question papers and revisions. From this part, we just say, guys, let's continue to revise, and also don't forget, guys, to share our videos to your friends and colleagues, okay? And if you are new, guys, don't freak out, be part of the family by subscribing, and also be a good citizen by just giving this information to someone. Okay, so that's it, guys, from Memo African Motives. Till we meet again.